more than once or not at all. It gives a letter of the species that is a negative ion.
This is October
Negative.
2024 paper, okay?
Okay.
This is
Uh,
October 2024. Yeah. And Unit 4CH1, paper 2C. So they are saying in part A, you may use each letter once, more than once, not at all. Give the letter of the species that is a negative ion. Of course, the species would be the one
D.
having more electrons than protons. So, of course, the answer
D.
would be
D.
uh, D for doctor.
Yes.
9 proton and 10 electrons. Yeah, exactly. D. Give the letter of the species that has a full outer shell of electrons. So full
Uh,
means it's gonna be
full
uh,
D as D as well.
D. D, D,
Yes.
D, 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 D.
2 and then 8.
Okay. Yeah, 2 comma 8. So it's D again. Give the letter of the species that has an atomic number equal to its mass number. Mass number is
So,
the sum of proton and neutron. Mass number
yeah.
is the sum of proton and neutron. So
A.
atomic number is equal to the mass number. A, yeah, because 1, 1.
Yes.
Explain why species B and C are atoms of the same element with identical chemical properties. A, like B and C. If you can see B and C, they have same proton and same electron, but they are
As
different. They have different neutrons. So of course, they are isotopes. So
yes.
why species B and C? So
Isotopes. Isotopes have different number of neutrons. However, they have the same amount of protons.
so what am I supposed to write in this?
Isotopes have the same number of protons but different number of neutrons.
So B and C are both
Isotopes.
atoms of the same element atoms of the same element having same number of proton and they have
Same chemical properties.
as they have same
Configuration.
yep. Configuration means that if you can see we have chlorine 35 and chlorine 37. So proton number is 17 for both. So if you would be writing electronic configuration, so the configuration would be 287. Means
Yes.
that they have same outer electron. So that's why I can say they would be having the same chemical properties. Okay, that's why. A proton has a mass of this and a neutron has a mass of this. Calculate the mass in grams of the nucleus of an atom of a species C. Means nucleus, but like in the nucleus, we have proton and neutron. We have
Yes.
proton and neutron. If you can see species C, that's that has 3 protons and 4 neutrons. So you know what I would be doing. So I have 3 protons and 3 protons, and then I have how much neutrons I had? 4 neutrons. 4 multiplied by neutron is 1.6740
Mhm.
exponent minus 24 and the proton has a mass of 1.6726 exponent minus 24, and then you would be adding them together, so you would be getting the mass in grams of the whole nucleus, because we know that nucleus contains proton and neutron. So that's why
Mhm.
I'm going to add them up. Okay,
Yes.
what's the answer?
Uh, 1 second. Let me just calculate it. Sir, it gave me a weird number, like with a letter E in it. 1 second. Let me just do the other
Okay,
number.
the answer is 1.1714 exponent minus 3, 23. That's the
Oh,
answer. Okay,
okay.
grams. Why metals are malleable? This is the diagram for metallic bonding. So you know why metals are malleable? Malleable means that they can be changed into any shape. They can be changed into any shape. So the reason is that it has a layered structure. You can see the layer of ions. It's a layer of cation. It's a layer of cation, basically, right?
Uh,
So they are going to slide over each other. They are going to slide over each other. So, and also electrons are free to move because they are saying they are good conductor of electricity. Electrons are delocalized into this and they can move throughout the lattice structure. That's the reason I can say it is a good conductor of electricity, and also this is a malleable. Okay.
okay.
Yeah. So I would be writing that metal has layered structure, layered structure of ions that can slide over each other.
Yeah.
And why metals are good conductor of electricity? So you will say that metals have delocalized electrons. Do you know what is mean by the term delocalized?
Yes.
What does it mean?
It means that it's free moving and it can carry charge.
Exactly. They can move throughout the lattice. Two methods of obtaining a metal from a compound are electrolysis and extraction using carbon. Explain without giving practical details which method is most suitable for extracting iron from iron 3 oxide. Iron 3 oxide is Fe2O3. So, of course, iron is less reactive. If you can see the reactivity series, in that series, we would see that iron is less reactive than carbon. We would see that iron is less reactive than carbon. So, of course, I can say that we can easily separate we can easily separate iron from its oxide by using carbon because carbon is more reactive. Okay,
Mm-hmm.
so we can do extraction of iron with carbon. Okay, so I'm
Okay.
supposed to write iron is less reactive than carbon. Iron is less reactive than carbon in reactivity series. So we can extract iron using carbon. A student has a solution of iron 2 sulfate and a solution of iron 3 sulfate. Iron 2
Mm-hmm.
sulfate means this would be FeSO4, and iron 3 sulfate means it would be Fe2SO4 3. Describe a chemical test the student could use to identify which solution is iron 2 sulfate. In this, iron is plus 2, and in this, iron is plus 3. And you know that Fe plus 3 is brown and Fe plus 2 is green,
Right.
light green color. So we have to write down a chemical test. So we are supposed to add sodium hydroxide into the both solutions. Okay.
Mm-hmm.
And then after adding sodium hydroxide, so the iron 2 sulfate would be giving us a green precipitate. A green precipitate. So when we would be having the green precipitate, so we can say that iron 2 is present. Okay. So
Okay.
I'm supposed to write add sodium hydroxide to both sample solutions. Sample solutions. Iron 2 sulfate would give green PPT, green precipitate, which means iron 2 is confirmed. A teacher uses this apparatus to separate a mixture of ethanol and water. Okay. Give the name of this method of separation. Of course, this is
Fractional
fractional
dissolution.
distillation. Yep. This is fractional distillation. So name the pieces of apparatus, label X, Y, and Z. So X
Thermometer.
is thermometer and Y is
Condensing.
condenser and Z is the beaker.
Okay. Yeah.
Okay, Z is the beaker. So this is beaker, condenser, and this was the thermometer.
Okay.
Give a physical test that the teacher could do to find out if the ethanol produced is pure. You know, um, for the pure substances, for the pure substances, if you have a liquid, so the boiling point should be fixed. So the boiling point should be fixed. Let's suppose I'm going to give you the sample of water, and I'm asking that is that water pure or impure? So you would be boiling that water. If the water is boiling at exact 100 degrees Celsius, so you can say that water is pure. And if it's not boiling at a fixed temperature, if it's not boiling at a constant temperature, so you would say that the water is impure. So
Yeah.
this is of 2 marks. So I would be writing in that. Uh, so take ethanol ethanol in boiling tube and boil it. If it boils at 78 degrees Celsius, then you can say ethanol is a pure substance.
Yeah.
A teacher adds a small piece of lithium to water and collects the gas produced. Give two observations when lithium is added to water. So lithium is Li, that is solid. It's going to react with water, that is a liquid. It's gonna produce LiOH, that is aqueous, and hydrogen gas. What do you think? What should be an observation? Like they are asking two observations. What do you think?
Um, there will be the lithium would vigorously react with the water, and it would expand into a sphere, I think.
Oh, okay, okay.
It would there would be bubbling or fizzing in the water.
Yep. There is bubbling. There is bubbling. There is fizzing.
Is there
There is
also a
effervescence.
lilac flame?
There is effervescence
Oh.
due to hydrogen gas. And another observation would be that I have taken a piece of lithium that is solid at room temperature. So after the reaction, it would disappear. After the reaction, the solid lithium disappear. Yep. See next one. They are saying um, the teacher adds a few drops of universal indicator. The teacher adds a few drops of universal indicator at the end of the reaction. Explain the final color of the universal indicator. As you can see, in the reaction, I got hydroxide. In the reaction, I got hydroxide. You know, lithium hydroxide is a base, is an alkali.
Mm-hmm.
So when you would be adding universal indicator into the solution, in the presence of alkali, it produces blue color. It's going to form blue color, blue
Mm-hmm.
color. So uh, changes to blue color as which is alkaline. This is the equation for the reaction between lithium and water. The teacher collects 550 centimeter cube of hydrogen gas at room temperature and pressure. Calculate the mass in grams of lithium that the teacher added to the water. 1 mole of gas at RTP has a volume of 24,000 centimeter cube, and they have given you the atomic masses of each element. So you can tell the mass of lithium. Yes, mass of
Okay.
lithium.
Okay. Calculate the mass in grams of lithium. The teacher collects 500 centimeter cubed of hydrogen at room temperature. 1 mole of gas at room temperature has volume. Okay, calculate. Okay, so first, this is the word equation. So I'm not really sure.
It's of 3 marks, but very easy question.
Okay. Um, for lithium, calculate the mass. So moles equals mass over mR. So we need to find the mass. So we have the mR of lithium, and we have the moles. So the lithium is 7. So we do 1 mole of gas at room temperature has a volume of 20. Sure, I'm not really sure. I forgot a bit.
Okay. So, first of all, I would be finding out the moles of hydrogen gas. So it's gonna be mole of H2, that is equal to given volume 550 divided by 24,000. So the answer is 0.0229. This is the mole. This is the mole. According to the equation, the mole ratio between lithium and hydrogen gas is 2:1. According to the given equation, if you can see the mole ratio, that is 2:1. I got the moles of hydrogen, that is 0.0229. So that would be X. X is equal to 2 multiplied by 0.0229. So that's equal to 0.0458 mole of lithium. This is the
Okay.
mole. They are going to find the mass of lithium. So mass is equal to Mr. Moles. Mass is equal to AR multiplied by mole. AR of what? AR of lithium. AR of lithium. So lithium is 7. So lithium is 7. That is this. And the mole is 0.0458. So the answer is, so the answer
So
is
how do you find the ratio 2 to 1? How do you find that?
because if you can see this, it's H2 and it's Li. Li is 2 and H2 is 1. So the ratio
Oh,
is 2:1. Okay?
okay.
Yeah.
Okay, okay, fine.
The teacher then adds a small piece of potassium to water. Give one observation seen when potassium is not seen with potassium, that is not seen with lithium. As we go down the group, reactivity increases. So it would be reacting with explosive manner. So it's of only 1 mark. So I would say that you can see the flame. You can see the flame,
Yeah.
or I would be writing that uh, with a lilac flame.
Mm-hmm.
Give lilac flame when react with water. Explain why potassium is more reactive than lithium. Yes. Why
Um,
potassium is more reactive than lithium? Refer to atomic structure in your answer.
Potassium is more reactive than lithium because atomic structure. Okay. Potassium has more outer shells than lithium due to yeah, okay, wait, I need to mention. So potassium I think is in period 4. and lithium is in period 1 or 2, I think. Let me just get the periodic table. Sorry.
Okay.
So lithium is in period 2 while potassium is in period 4. This means that lithium will have two outer shells, while potassium has 4. Um, the farther away in group 1, the farther away the outermost electron is from the nucleus, the weaker the electrostatic forces of attraction between the nucleus and the electron are, meaning that it can be lost much more easily, while lithium has only two outer shells, meaning that
Yes.
the electrostatic force of attraction will be stronger to that one electron compared to potassium. That's why potassium is more reactive.
Yeah, that's why. So I would write that potassium is larger than lithium as potassium has more shells. As
Yeah,
potassium has more shells.
yeah,
So it means that outer electron will be further away from the nucleus. So it's loosely attracted towards the nucleus.
mm-hmm.
Can be removed easily. If this is lithium nucleus, this is an electron. So this is potassium.
Yeah. The electron's much farther away.
Yeah, more distance. So means that less attraction. Are you getting my point?
Yeah.
Okay, it's easy. A student does some titrations to find the volume of dilute nitric acid needed to exactly neutralize 25 centimeter cube of sodium hydroxide solution. This is the student's method.
We
Add
haven't
25,
done it. We
sorry,
haven't done neutralization.
it's
Oh, never
titration.
mind. Never mind. Sorry, titration. Yeah, we have
Yeah.
done it.
So add 25.0 centimeter cube of sodium hydroxide solution to a conical flask. Add 3 drops of methyl orange indicator. Fill a burette with an acid. Add acid from the burette until the indicator changes color. Record the volume of acid added. Give the name of the apparatus that the student should use to measure the volume of sodium hydroxide solution in step 1. They are measuring 25.0. 25.0. It means that we have to take exact volume. I have to take exact volume. Okay. So the accurate apparatus is pipette.
Okay.
Give the color change seen in step 4 because you have added methyl orange. Okay. I'm going to add acid from the burette and I have sodium hydroxide in a conical flask. So in the end, after neutralization, I would see the color is changing from yellow to red.
Yes.
Yellow color is present in
Methyl.
base.
Yeah.
Okay.
Okay.
Yellow to red. Yellow means Yellow is present. You can say I have a conical flask. In that conical flask, I have sodium hydroxide. So when I have added few drops of methyl orange, so that was yellow in the presence of base. And
Yeah.
when I'm going to add acid from the burette, so it would change from yellow to red, means that at that time I would be having acid. So red in acid and yellow in base.
Yeah.
Yep.
Okay.
Give a reason why the student does not use universal indicator in this titration.
Uh, I'm not sure.
You know, indicators changes their color according to the pH values. According
Mm-hmm.
to the pH values, some indicator change their color, like some indicator change their color immediately, like sharp change in color. So of course, when the indicator is going to change like immediately its color, so it means that we would be having some sort of difficulty in measuring the end point of that titration, because suddenly it
Oh,
would be changing its color. So we cannot determine at what exact volume it has changed its color. So that's the reason
okay.
universal indicator change its color sharply. So that's
Okay.
why universal indicator change color over a range of pH values, over a range of pH values. So, or you can say
Okay.
that it has no any clear point that at that same point, at the fixed point, it's going to change its color. No. So that's why we are not supposed to use universal indicator. It's not an accurate. It's not an accurate even. So I would be writing that universal indicator.
Sir,
Yeah,
I have another class in about a few minutes.
does not give, okay, a sharp color change, sharp color change, okay,
Mm-hmm.
as color change is too gradual.
Okay.
So we would be having difficulty in measuring that color. Okay.
Okay.